All right, number 3. So on the figure below, draw a 3-by diagram showing all the forces on the block. And we have an F1 right here. We have a rough horizontal surface, so we certainly have a friction. Okay. And we have a normal force. We have force due to gravity. Okay. Do you get 4 forces? Yes. Okay. And derive an expression for the normal force exerted on the surface on the block. So that means what we need to highlight is our F1, because we need to split the F1 into F1x and F1y. Well, specifically F1y, because we're looking at the normal force. So F1y would be F1 sine theta, opposite side. Okay, so F1 y is F1 sine theta, and then so if you add up all the forces together, it should equal to 0. So normal minus plus F1y minus Fg is equal to 0. So the normal force is equal to Fg minus F1y. And since it says that all the algebraic expressions must be in terms of those characters, so that means we will have Fg would be simply mg minus F1 sine theta. Same? Yes? All right, so that's the part C. And then part B, sorry, part B. And then part D. That's part C. And let's go ahead and take a look at part C and part C first. So let's go ahead and develop an expression for the coefficient of friction. Okay, mu, coefficient of kinetic friction, mu between the block and the surface. So we will definitely, does it say constant speed? Is a constant force. The acceleration is a1. Okay. So derive an expression for the coefficient of friction. So F net is not 0. You're correct. F net is not 0 in this case, in the x direction. So if you want to find out the mu, well, mu can only be found, or just mu right here, it can only be found if you have the friction over the normal force. Now, we've got the normal force up there already. So the question is, how are we going to find out the friction force? Okay, how are we going to get the expression of the friction force? F net is not, well, F net in the x direction is not 0. F net in the y direction is 0. Because the block is still on the surface. Okay, if you pull the block to the point that it lifts up the surface, then the F net in the y direction will not be 0. So, but F net in the x direction is simply equal to m times a, or m times a1, to be more specific. And F net, it'll be F in the x direction, or F1x, minus friction. It's equal to m times a1. So that means your lovely friction would be F1x minus m times a1. And F1 in the x direction is simply F1 times cosine theta. So we will go ahead and put this lengthy, not so pretty expression over here. And it's okay. Okay? It is okay. All right. So far, so good. Okay. I hope you are getting more accustomed to these kind of expression writing, equation setting. Okay. Don't get scared about it. Make sure you know when the net force is equal to 0, when it's not equal to 0. All right, part D. On the axes below, sketch the graphs of the speed and the displacement x of the block as a function of time if the block started from rest at x equal to 0 and t equal to 0. All right. Did you draw the graph yet? Nope. Go ahead and draw it. All right. So on a VT graph, what must be shown? What is the main feature that you must exhibit on the VT graph? So what kind of curve, what kind of line should we draw, basically? Straight line, right? With a positive slope. So we can go ahead and do this way. Okay. That will be the case. Now, if this is the case, how would we draw our displacement time graph? Well, we start from here. That's what the question says. Is it okay that we draw this? Yes or no? Go ahead, think about a reason to support or to argue against it. Should we? Yeah. Correct. Okay, that's a good argument against the drawing right here for the displacement time graph. If you draw a straight line, that implies it has a constant velocity, and we do not have a constant velocity. The velocity is changing. So that's no way to draw a straight line like this. So what should be the line that we draw? Concave down or concave up? Now, if you say concave down like this, then concave up like this, the slope is increasing. Yes, the velocity is a slope, right? So the slope is increasing. So if you're in calculus, you would see this a lot better. And in pre-calc, for AP pre-calc, we learned about concave up and concave down, right, earlier. So this is how you think about the slope of the graph. And if you can look at the tangent line, basically, that's the instantaneous velocity, and that corresponds to these 3 dots. Okay, the velocity is the slope of the displacement time graph. All right, last part, E. Okay, take a look at part E. Part E says if the applied force is large enough, the block will lose contact with the surface. Derive an expression for the magnitude of the greatest acceleration that the block can have and still maintain contact with the ground. Okay. Do you understand what the question is asking? Do you? F1y is equal to FG. So it's more like this. Now the acceleration, we're talking about the acceleration in the x direction, right? And that is directly dependent on the applied force F1. So what it is indirectly saying is that what is the force? All right, like if you pull at an angle and if you pull enough with enough force, you're going to lift the box off the ground. So we're saying, hey, please don't do that. So where should we set a limit on the force or, well, acceleration? Okay, so think about that we have F max, F1 max, okay, or F1 max in the X direction. It's going to be F1 times cosine theta, which is equal to m times a max. A max right here. Okay, so we're saying, hey, what is the maximum acceleration? Okay, what's the maximum acceleration over there? So could you take 1 minute and see if you can generate an expression? So we have the equation over there. So F max is going to be a m times a max, right? Now, in order to lift it off the ground, that means you will have to have the force, the applied force in the y direction would also be great enough to overcome the weight of the box, right? So that means F1y or F max y, that would be the plus force minus mg is equal to 0. So F max in the y direction would be F max times sine theta. It's equal to mg. So F max is equal to mg divided by sine theta. Okay. And then what else? Fg is equal to this. And then and over here, that's the blocking. And A maximum, it's going to be F max cosine theta all over mass. Okay. So now we don't have, so the problem now on this algebraic expression is that we're having this F max right here. And we could not use F max. We cannot have F max in the final expression. So that's the reason why we take care of both directions and say, all right, A max is F max cosine theta over m. And we are going to substitute this with mg sine theta. So mg sine theta, oh, sorry, mg divided by sine theta. Mg divided by sine theta times cosine over m. The m would get canceled out. So so the final expression would simply be g times cotangent theta. Okay. Now, I don't expect too much on this kind of stuff right now. This is the first time we have done all these algebraic expressions. So what we did today is really more of an exposure to get you started on this kind of writing, this kind of thinking, that we are not working with numbers. We're working with expressions, and they do have certain requirements for the expressions, such as you can only use certain letters, like these guys, as your expressions. So so that's something I want you to get comfortable with, and we'll do more of this next week. Which one? Cotangent, which is 1 over tangent. So tangent is sine theta over cosine theta. Cotangent, which you will learn in pre-calc very soon, is cosine theta over sine theta, which is the reciprocal of tangent. Oh yeah, that would definitely help.